the kinetic model of energy, the kinetic model of matter, rather, it does really a lot for us. It cooks, it cleans, it mows the lawn. It explains the relationship between energy and temperature. And it also gives us a frame of reference to understand how pressure comes about. Oh, I don't think it actually cooks or cleans or mows the lawn, though. So really just the last two. We can understand pressure by thinking of these particles in the kinetic model as moving around a lot. These are gas particles. They're really big gas particles for the scale here, but they're gas particles that are moving around with some speed. And if we follow these gas particles, we see that they're going to have collisions. They're going to hit the side walls, and they're going to collide with each other as well. So these things are just kind of bouncing all around here inside the container. And so all these are doing this. They're crossing paths, they're hitting each other, they're hitting the walls. And every time we have a collision, we have a transfer of energy. So that particle is going to change direction as a result. And then we know from Newton's third law that that particle isn't the only thing that's going to experience that force. When the particle hits the wall of the container, not only does the particle get a force, but the wall gets a force as well. So the particle is getting a force back into the container, the wall is getting a force away from the container, or away from the inside of the container. So the wall is being pushed outward by these gases on the inside of the container. Well, we describe that as pressure. If we have some object on the inside, then we would expect that collisions with that object on the inside would cause pressure on it as well. Now, if we have faster moving particles, those particles are going to get to the wall more rapidly, so they'll hit the wall sooner, and they'll bounce off and hit the next wall sooner, and bounce off and hit the next wall sooner. So we end up with just a larger number of collisions with faster particles. And then those collisions are going to be more energetic. We can think about a car crash involving two cars that are driving in a parking lot versus two cars driving in a highway. They're moving a lot faster. It's a lot more energetic, a lot bigger forces involved. So when those particles that are moving quickly hit the side walls of the container, that sidewall feels a bigger force. It feels more pressure. So with larger temperature comes larger speeds for these particles moving around, zooming around like crazy. And with those larger speeds come more frequent and more energetic collisions, which means a higher pressure. So there's a relationship here between temperature and pressure for gases in some container of a fixed volume. As temperature increases, the pressure increases with it.